Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called 9999 by Black Doom, and you will see soon why it's called 9999. Here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Digits cannot repeat on the marked diagonal, so you cannot have repeat digits along this diagonal. Killer cages. Digits in a cage cannot repeat and must sum to the given total. And there's always two digits, and they're always adding up to 9. So that's where you get the name of this puzzle, which is 9999. I think that's also wordplay in German of saying no, essentially. So no, 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 or it could be no, nine, no, nine. Who knows? If you're speaking like a combination of German and English. Um, Actually, nine is also. I think that's also nine in German too, but not spelled that way, obviously. Okay. Anyways, yeah, that's how killer cages work. The funny thing is we don't have 9 along these diagonals, which is the little killer clues. The clues outside the grid show the sum of digits along the indicated diagonals. So therefore, these 6 digits must add up to 25, and these 6 digits must add up to 24. And that's how little killer clues work. And then crop key. Digits separated by a white dot must be consecutive. Not all dots are given. So for example, if this were a 3, this would have to be a 2 or a 4 to be consecutive with it. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first thing that I saw was these 4, in box 5, there are 4 2-cell cages adding up to 9, which means the remaining digit must add up to 9 because 9 times 4 is 36. 45 minus 9 is 9. Or sorry, 45 minus 36 is 9. Therefore, this must be a 9. Therefore, along this diagonal, there can never be a 9. And in addition, any cages with 2 digits adding up to 9 can never contain a 9. So these can't be 9 because of the killer cage constraint, and these can't be 9 because of the diagonal constraint. Where is the 9 in box 9? It must be here. Let's see. Where is the 9 in column 4? It can't be any of these 3 cells because all these cages add up to 9 with 2 digits or more, so therefore these cannot be 9. Similarly, these can't be 9, but also because of the cages, but also because this has to be a 9. Therefore, it must be one of these 3 cells, but it can't be here because of that 9, so it must be one of these 2 cells. Where is the 9 in... Actually, I guess box 2, right? Can't be these because of this 9. Can't be these because of... and these because of... they've been requiring 2 digits adding up to 9. Therefore, this has to be the 9 in box 2. Where is the 9 in box 3? Can't be here because of this 9. Can't be here because of that 9. Can't be here because there's 2 digits adding up to 9 in the killer cage. Therefore, the 9 must be one of these 2 cells, which eliminates 9 from this row and eliminates 9 from here. These can't be 9 because they have to have 2 digits adding up to 9. Therefore, where's the 9? It must be here. Oops, not 3. This has to be 9. That eliminates 9 from this column. And in box 7, then, where's the 9? Cannot be any of these because 2 digits adding up to 9 can never contain a 9. Can't be here. Therefore, it's one of these 2 cells, which eliminates this from being a 9. Therefore, where is the 9 in box 8? It can only be here now. So this is 9. Um, what else do we have? Where is the 9 in box 4? It could be one of these three, oops, one of these three cells. Because it can't be these, it can't be these because 2 digits adding up to 9 can never contain a 9. What about this? It can't be any of these, so it's one of these two or that one. Okay. Hmm. Hmm. We have cages that add up to 9. This must be consecutive. That's interesting. Hmm. So other than the 9, every other cell in a cage, or sorry, in the box, must be with a pair, which add up to 9, right? And since we have so many 9 killer cages, we should probably use that then. Um, hmm. I'm not sure how, though. Oh, I am sure how. Well, not quite, but we'll see, figure it out. This is a pair that add up to 9. Obviously, they cannot be either this pair or this pair, because one of them would have to be in this area if the other one is here, right? And they can't be because they're both along this row. So it cannot be this and this. It cannot be this one. There's also a pair of digits that add up to 9 in one of these three cells, right? The other one is a 9, but then the other two add up to 9. So, but it can't be this one, which means that it cannot, the corresponding red cannot be here. Where is the red? Where are the two red cells that make up this 9 then? It cannot be any of these, cannot be any of these. Therefore, it must be these two specifically. Okay, what does that tell us? I'm not sure. Um, okay. Where are the red cells? Okay. The red cells along this diagonal cannot be these three cells, right? It cannot be both this one and this one because those are separate 9. Those do not add up to 9 because they add up with another digit to add up to 9. So this one adds up with that digit to add up to 9. This one adds up with another digit to add up to 9. Therefore, these cannot both be the red. So one of these three must be at least one of the reds, which means this can never contain both of the reds, and this can never contain both of the reds. So the reds must be either two of these along this diagonal, but it can't be this one. So it's either this, or it could be both, or it could contain this one, right? So it can never be one of the full cages that are in the cell. If this is a full cage, that's red. All three of these are eliminated from being the red. All three of these are eliminated from being the red. And if therefore these two would have to be both reds, but that means this would add up with another digit to add up to 9, and same with this one, and that's not possible. So we know the red has to be one of these, has to be two out of these three cells. Um, hmm. It has to include one of them, obviously. Um, Similarly, where is this cell? So we're going to make this orange. These two cells obviously cannot be both here. None of them could be here. If it were one of these two cells, so I say it was these two cells, none of these could be orange, which would force both of these to be orange. But that's not possible, right? Because these two add up with other digits to add up to 9, but then this would be that would contradict these two digits adding up to 9. Therefore, orange cannot be either of these two cages, and it must be the remaining cages. So orange has to be some combination here. We know one of the oranges is here. We don't know where the other one is. This obviously can't be orange or red, so this will label it a different one. This is yellow. Okay. This can no longer be yellow, and it can't be orange, and it can't be red. So we're going to make that the last color, and we're going to say it's blue, right? So one of the blues is here, and one of the blues has to be here. Therefore, the other one's blue, the other one's yellow, right? So both blues are along this line. Blue, so this is blue or yellow, and this is blue or yellow, because those are the only remaining sets of 9 that we have, right? Blue, both blues are along this line. So blue cannot be here. So it can't be either of these. And therefore, this is blue or this is blue, right? Yellow cannot be here. We know this is blue and yellow. This is blue or yellow. One of these has to be yellow. So one of these is yellow. And it cannot be this one. Because if this is both yellow, that would force that to be not yellow, which is impossible because we know that is a yellow. So this can't be yellow, which means this has to be the yellow. So this is yellow. One of these two is blue. This has to be red or orange. We're not sure which. And one of these obviously is red or orange, but we're not sure which. Again, this is red or orange, and this is red or orange. This can't be red. We know orange is here, but that's only one orange. So that doesn't eliminate all possibilities there. So therefore, this has to be orange or red. This can't be yellow because we have two yellows here. So it's either blue, red, or orange. This cell cannot be yellow. And, right, where is this cell then? This can't be yellow because they would eliminate both possibilities of yellow for there. This can't be yellow because of what's on the diagonal. We know there's a yellow here, so the other yellow has to be here. So where is this yellow? It cannot be any of these three. It can't be any of these three. And it can't be here. So it must be this one, which makes that a yellow then. So this is yellow. This is yellow. The rest of this is blue, orange, and red. Obviously, red cannot be here. So this is blue or orange. This is yellow, so this is also blue, red, or orange. One of these has to be yellow. And this number specifically corresponds with this. Okay, so then where is this number then? This number has to be one of these two, obviously, and then it has to be one of these three. So either this is yellow or this is yellow. We're not sure which. But yellow can only be in one of these in either these two cells or these two cells. We're not sure which again. Okay. Huh. Let's see. What else do we have? This cannot be red, but it could be blue or orange, though. This could be all four. So that's not helpful, but... Hmm. Hmm. What is the corresponding other cell that's not in a cage in column 1? It has to be a red or orange, right? So this has to be either red, orange, or 9. And this is also red, orange, or 9. Obviously, this can't be red. So this is specifically orange or 9. But we don't know, right? Hmm. Where is this cell? This spell specifically... Oops. This cell specifically, let's label it A. Cannot be this cell, any of these cells, obviously. It can't be that cell because that adds up to 9 with another digit, and therefore this would not work. Similarly, can't be here because the digit that it would have to be with would be the same as that. So this can't be A, this can't be A, and this can't be A. A has to be one of these two cells. Okay. A cannot be along the diagonal. A can't be one of those two cells. Therefore, where is A? If this were A, so it can't be here or here. It can't be here or here. Therefore, it's either here or it's here. If it's here, it has to add up with its partner to add up to 9. But then the partner is right there. So this cannot be A. Therefore, this must be A. And it must be with its partner, B. So this is specifically then AB. This can't be B. Where is A, though, along it? It has to be one of those two cells. So A is here. AB is here. The yellow is the same here. This can't be A or B. This is now C or D specifically. And obviously can't be here. This can't be A, B. This must be C and D. So therefore, this cannot be blue. This has to be red or orange. One of the yellows has to be here. What about this? This is E, right? The yellow cannot be... There's one yellow on this, which would be F. Therefore, this must be E also. This is F. One of these is F. E cannot be here. E cannot be here. E cannot be here. So E has to be one of those two cells. This is E or F. We therefore know this is C or D. This has to be G or H. Or G and H. This is specifically then A and F. This is obviously G and H. We're not sure which though. This is E, which forces this to be F, right? We know F is one of these three. F can be one of these two. So this is specifically, what do we have here? This is G and H, and this is AG and H. So this is E with CD and B. Therefore, this is not A or B. It's not E or F, because both of them would be eliminated here. It's not G or H, because it can't be both of those. Therefore, this must be C and D. So this is C and D, which means this can't be C and D. This could be E, F, G, or H, which means this could be E, F, G, or H. Again, we'll make this G and this H, I guess. This is also E, F, G, or H. So this is C and D, which means this cannot be blue. Right, this is one of... So we have orange or red and orange or red. These cannot be orange or red then. This has to be blue and yellow, and this is blue or yellow. This can't be yellow, though. Therefore, this must be the blue. So this is blue, which is a G or an H, because it cannot be E or an F, and it can't be C or D, which we know is not a blue. Therefore, this is a blue, which makes this G and H the blue. So this is blue. This can't be blue anymore. This can no longer be blue because it would be both of those possibilities there. Therefore, this is yellow or orange. This could still be blue, red, yellow, or orange. So those are still possibilities. This is G and H. This is G and H. One of them's here. So we have two blue. Okay, so this cannot be that blue specifically, but it could be either of them. This is one of C or D, and it's with G and H. So this cannot be C and D, right? Because it would be this. It would eliminate all possibilities here. Therefore, this can't. Right, this can't be orange. This has to be the red. So C and D are red. A and B must be orange. So it can't be red. This is orange and orange. Therefore, we have both oranges in box 1. So these two are red. This can't be orange. This has to be red. So this is red. This is red. These are C and D. This is A and B. A and B's are the orange. So this can't be orange. This is red. This is red. This is red, so this can no longer be red. This can't be red either. So this has to be then... This can't be red, but we know this combination of the two outside the cage must be the red cage. So this can't be red. This is this can't be orange anymore. This can't be orange anymore. The two reds have to be in these two spaces. So this can never be 9, which forces one of these to be 9. So this can't be 9, and therefore we know This specifically is a 9. One of these two is a red. These can't be red. This can't be red. Where is the last red in box 4? Can't be here. Can't be here because of the 2 digits adding up to 9. Can't be here. Must be here. So this is also red, which means it cannot be 9. Therefore, this is a 9, which means that can't be 9. So where's the red now in row 5? Cannot be here because we have both reds there, so that eliminates that from being a red. This must be a red, and therefore this must be a red. So those are all the reds we have left. This has to be B. Oops. This has to be B. This is A. This is blue, yellow, or orange. This can't be orange. This can't be orange. I guess this could be orange, possibly. This is orange and yellow. Where is A? A has to be one of in rows 8, 7, or 8 in box 8, and it has to be in row 7 or 8 in box 9. So it has to be one of these 3 cells in box 7, but it can't be this one because of that. That can't be A. Therefore, A is one of these 2 cells here. This can't be C or D. So it's B or E specifically, which means this is orange or it's yellow. What about these? This is red. So this can't be orange here. This has to be a blue, and this is blue or red. This red cannot be 1 or 8, right? 1 only has 1 consecutive digit next to it, and 8, without a 9, has only 1 consecutive digit next to it. So this is 2, 3, 4, 5, 6, 7. So this must add up to 7. So it's 2 through 7 and 2 through 7. Okay. What are the remaining cells here? They have to be A, B, no C or D. It could be E, G, and H. So this is A, B, E, G, H. I know H. A, B, E, G. And this can't be A or B. So this is E or G. One of these is A, B, E, or G. So if this is A or B, it would be with the other A or B. If it's E, it would have to be with F. And if it's G, it would have to be with H. That's possible. This has 2 reds. Well, okay, so this is blue or yellow, right? We don't know which. It cannot be red, obviously, and it can't be orange. So this is blue or yellow, which means this is also EFGH, right? And interesting. So whatever is in this cell, it cannot. Okay, whatever's in this cell, or these cages, this killer cage, it cannot be in these two cells, right? Because this one would have to be one of the corresponding ones here, and it can't be if it's here. Therefore, this matches with whatever this is. Because of that, they can't be here. Whatever's in this cell must be here, and it cannot be this cell because, again, one of the corresponding ones would have to be here. Therefore, it must match this. Oh, this can't be B. Hmm. If this is A, this has to be the corresponding B because we know those two add up to 9. Therefore, B can never be in one of the other 9 cages if this is A. So this would be B, this would be A, this would be B. And therefore, B in column 5 could not be either of these two cells. If this is A, this would have to be B, which would make that A, which would make that B, and B still could not be in one of the corresponding 2 cells here. Therefore, this, either way, B can never be either of these 2 cells, which means we have a CD-CD pair, so this is the other red, and this can't be C or D because we have a CD-CD pair in column 5, so therefore this must be E and this must be B, which means this can't be yellow, this is orange, this has to be the other orange then. Sorry, the other yellow. This can no longer be E, which means this can't be F. This is orange and B. B could be either one of these two, or it could be either of these. Again, this can't be B because of this. So this can never be A. If this were A, where's the B in box 4? Can't be here because of this B. Can't be the red ones. And can't be any of the 9 cages. So therefore, this can never be A. So now we have an EG pair in row 6. So the rest of the row cannot be E or G. Therefore, this is A or B. And this is A or B. Since this is A or B, this must be also A or B. So this has to be the orange. So this is orange, which means this can never be yellow. Sorry, this can never be orange. This has to be yellow. So this, therefore, this is E and F. This can't be E because of the EF pair in box 4. Therefore, this must be G, which makes that an E. The G is blue. The blue can only be here then. So therefore, this must be H, which means this can't be blue. Therefore, this must be yellow. And this can't be yellow anymore, so this must be blue, which means this is G and H. So we have a GH pair in row 2, or sorry, row 3. So this can no longer be G or H, it's E and F, which means this is not blue, this is yellow. This is also yellow. So we have both yellows here, we have both yellows here, we have both yellows here. This can no longer be yellow, so this is also blue. This can't be E, this can't be F, therefore this is both yellow. This cannot be A, so this must be A, which forces this to be B, which means this is A, which means this is B, which means this is F, this is A, this can't be A. We have 2 blues in row 9, so this can no longer be blue, which means this is yellow, which means this is the F. This can't be yellow, so this is blue. And it can't be F. This must be the E. This must be F. This is A, this is B. A or B, so this is orange. This is C or D. We have 2 reds in column, or row 7. So the rest of the row cannot contain a red. Therefore, this is blue. We have 2 blues in column 6 now. Therefore, this can't be blue. This must be red. Okay. What's left over? This has to be H. Therefore, this is G, which makes this H. This has to be G, which forces this to be H, which means this is G, this is H. Let's just label one of these C or D. We'll make this C and this D, which makes this a C, and that makes that D, which makes that C, which makes that D, C, D. This can't be C, so this is D, this is C, this is D, this is C. This is A or B, but we don't. Okay, so this is orange. These are orange, but we don't have any other restraints here. So we're missing a G. So one of these two are G. This can't be yellow. Because both of the yellows are here. Therefore, none of these could be yellow. None of these could be yellow. This has to be the other yellow. We have 2 reds, and we have... So either this could be orange, or it could be blue. But if it's orange and orange, does that ever work, right? If this is odd, these would both be even. If this is even, these would both be odd. And either way, they would add up to essentially an even number, which is not 9. So this can never be orange. This has to be the blue, which means this is G. This has to be the orange. This can no longer be H. Well, this is orange. This is A or B. This is E or F. None of these can be blue, so this can't be blue. This can't be red or yellow, so this has to be orange then. This is the other orange, so this is A or B, which means this can't be orange. We have 2 oranges in row 1, so therefore this must be blue, and it's G and H. This must be blue, and it's G and H. And this must be blue too, because where is the other G? G or H is here, but then this also has, where's the other one, right? It can't be any of these. In box 3, it can't be that one, so it must be here. So this is the other G or H, which means this cannot be 9, which means this is the 9, and obviously this can't be 9. So therefore this is 9, and therefore this is the other A or B. This is the other A, B. It's orange. These are both G and H's. Okay. What does that mean? I'm not really sure. Oh, we do have things that add up. Okay, so this is specifically... Okay, so this has to be A, and it's orange. We know these two add up to 9. So therefore this is 18. So we have 3 digits adding up to 4. Sorry, 7. Right? 25 minus 18 is 7. And these are 4 unique digits. So H and D are both 1, 2, or 4. Right? H and D are 1, 2, and 4. These two add up to 9. So if A, D, and H, one of them has to be 1, 2, or 4. The other one has to be 1, 2, or 4. What are G and H? G and H can never contain 1, 2, or 4, so they must be 3 or 6. Well, the only thing that corresponds to, which can be consecutive with 1, 2, or 4, is 3. So therefore, this has to be 3, which makes this a 6. And this is 2 or 4. We're not sure which. So all this must be then 6. This must be 3. This must be 6. This is 3. We just don't know which one's G and which one's H. E and F, one of them's 1, 2, or 4. And this one is H is also 1, 2, or 4. So therefore G... Oh, wait, hold up. That's wrong. Okay. So it cannot be 3 and 6 then. That's not right. H is one of 1, 2, or 4. Okay, so E and F, one of E and F is 1, 2, or 4. D is one of 1, 2, or 4. H has to be 1, 2, or 4. If H were not 1, 2, or H has to be 1, 2, or 4. Say this was G, though. This would be then 5, 6, and 8. But if this is 5, this would then have to be 4 to be consecutive with it. But it's not possible because 5 would have to be with 4 here. So this can never be G then. This has to be H. And the only ones that are consecutive with G and H, right? So if this were G, it would have to be 5, 6, or 8. And the only one that's consecutive with 1, 2, or 4 is 5. But then that would be 5 and 4 together. And then these two digits could not add up to 9. So this could not be G. This has to be H, which means it's 1 or 2. Which means D has to be 1 or 2 also, because those are consecutive. Therefore, we have a 1, 2, 1, 2 pair. This is 7 or 8, and this has to be 1 or 2. So all the G's are 7 and 8. All the H's are 1 and 2. This digit has to be a 4 to add up to 7, right? Because we know all three of these digits are unique, it has to be 1, 2, and 4 specifically. Therefore, this must be a 5. So all the E's and F's are 4s and 5s. This must be a 5. This must be a 4. So this is 4 and this is 5. This is 5 and this is 4. All the rest of these are 4 and 5s. Okay, so then we know this adds up to 9. So this is 7 and 8. That can only be next to 6 and 7, which can only be next to 5 and 6. And we have a 4, 5, 4, 5 pair, so we know this cannot be 5 because of the 4, 5, 4, 5 pair eliminates 4 and 5 from the rest of the box. So this is 6, this is 7, this is 8, which means all the blue 7, 8s. Why is it? Ugh. Anyways, okay, so this has to be 8. This is 8. This has to be 1. This is 1. This is 8. This is 2 then. This is 1. This is 8. This is 1 and 8. This is 1. This is 1. This is 8 and 1. This can't be 4, 5. C and D. C. So D has to be 2. So these are all 2s. And the C's have to be all 7s. Therefore, A and B's have to be 3 and 6. This can't be 6, therefore this is 3, which makes that a 6, which makes that 3, which makes this 6, and makes that 3. This can't be 3, so this is 6, this is 3. This has to be the 2, which makes this 7, which makes this 2, which makes that 7, makes this 2. This has to add up to 24. We know we have a 9 here. This is 3 or 6. We're not sure which, though. How does this ever add up to 24? These are 11. So these 3 must add up to 13. Can it ever be 3? It could be 3 if this is 5 and 5. That's possible. Can it be 6? It could be 6 if it's 4 and 4. No, because it has to add up to 13. So 6 can never be the case here. So this is a 3, which means all the B's are 6s and all the A's are 3s. So then 3 has to be with 5 and 5. This can't be 1. This is 8, which makes that 1, which makes that 8, which makes that 1. This has to be with 5 and 5 to add up to 24. So this is 5, which makes that 4, makes that 5, which makes that 4, which makes that 5. That's a 4 now. This is also Sudoku. This is 5. This is 4. So this cannot be 4. This has to be 5. That's a 4. This is 4. That's a 5. And that's a 4. And that's a solve. Yeah, challenging. I would put this in challenging also. I like it because I like coloring a lot, and that helped a lot. Though I think the letters were really the one that broke things apart, right? Well, the coloring was very important too, right? They were both useful. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.